Hello everyone, welcome to our YouTube channel. Today we are diving into a classic coding problem to check if a number is palindrome or not. I will walk you through the problem, examples, and how to solve it step by step in Java. We will first discuss the logic and then implement two approaches, one using strings and one purely mathematical for a more optimized solution. You can find this problem on LeetCode with name Palindrome Number. It is described here as given an integer x, return true if x is a palindrome and false otherwise. Now to solve this problem, we must know what is palindrome. So let's try to understand what is a palindrome number. A palindrome number is a number that reads the same backward as forward. Now, what does it mean? Suppose we have a number x equals to 1, 2, 1. Now, if we start to read it from forward in this direction, then we will get first 1, then 2, and then 1. And now again, if we read this number from backward from this direction, then we will first get 1, then 2, and then we will get 1. Now if this both the numbers which are read from forward and read from backward, if both the numbers are equal, then this number is a palindrome number. Suppose let's take another example where x is equals to 1, 2, 3. If we read this number from front, then we will get f is equals to 1, 2, 3. And now if we read this number from backward, then we will get first 3, then 2, and then 1. Now if we compare these both numbers which are read from forward and backward, and if these numbers are not equal, as clear in this example, these numbers are not equal, then this number which we have took initially is not a palindrome. Not palindrome. This is the only thing we are asked in this problem to do. Let us move to LeetCode to check if there any constraint is given or not. So here we can see we have only one constraint that says that x should be greater than or equals to minus 2 to the power 31, and it should be smaller than or equals to 2 to the power 31 minus 1. Now here if you see, you will get that this is the limit of integer in Java. So we are indirectly said that the given number x is always an integer. This constraint will help us a lot, as now we will not have to consider other type of numbers such as float, double. We have seen what is palindrome, we have seen the constraints. So let's try to code this problem using the string approach. So the first condition that we know is if any number is negative, then it cannot be palindrome given in any case. So the first condition that we will write in our code is if x means the given number, if it is smaller than 0, then we will simply return false. Now what we have to do, we will convert the given number into a string to read it from forward and as well as backward direction. So in the second line we have written a string str is equals to integer dot to string x. This line will convert the integer x into an string str. Now in next line we will create a new string reversed, which will store the reverse of the original string str. This is written here, string reversed is equals to new string builder str dot reverse dot to string. It will create a new string reversed. Now we have to check if both the string, that is the original string str and the reversed string reversed, are equal or not. If both are equal, then we have to return true, otherwise false. Now for that I have written return str dot equals reverse. Now in this line will return true if both the strings are equal, and will return false if both the strings are not equal. This is the basic simple approach using a string which we can use to solve our problem of palindrome number. This string approach will have the time complexity of big O of n and a space complexity of big O of n. Now let's try to optimize this space complexity using the mathematical approach. Now, let's make it more efficient by solving the problem without converting the number to a string. We will reverse the number mathematically. Now, how it will happen? If you see in our string approach, what we were doing, we were just reading the number from starting and from the ending, that is from forward and from backward, and were checking if both the numbers are equal or not. Now we will do the same approach but without converting the number into the string. How it will happen? We will first store this number into another variable as original number, which will have the original number, that is x, and we will create another variable that is reversed number, which will store the reverse of this number, that is then this number from backward direction, that is this one first, then 2, and then this 1. Now how it will happen? How we can reverse this number? If you see, this will happen in 3 steps. What we have to do? We will first extract the last digit from the given number, that is 1, and we'll add this number into the another variable. Suppose we have reverse, we will add or append this last digit in the reverse number, and in third step we will remove this digit from the original number and move to the last number, that is 2. Now we will take this number and append in the reverse number. Now in third step we will remove this. Now the 1 will be the last digit, so we will take this number and append in this. This is how we can get the reverse of any number in 3 steps. Now we will check if the original number and the reverse number if are equal, then we will return true, and if both are not equal, we will return false. You can see in the code we have written if the number is smaller than 0, that is the number if is negative, then we will return false. That is the basic condition. Now in second line we have written, we have taken an integer original which will store the value of x and created an integer reversed which is initially 0, but we will store the reverse of x into this reversed integer, that is reversed variable. So now in this while loop we are reversing the original variable to store it in a reversed variable. This is done while x is greater than 0. We are getting the remainder, that is last digit of the number in this line, and adding it into the reversed number, and then in the third step we are removing the last digit of the original number. This process is continued till we don't get 0 on the place of x, and in last we are checking if the original is equal to reverse. If both are equal, then this will return true, and if both are not equal, then this will return false. In this case, we will have the time complexity of big O of n and a space complexity of big O of 1. We can see it is optimized here. In our string approach, we were having the time complexity as big O of n and space complexity of big O of n. Here we can see the time complexities are same, but the space complexity is reduced. So this is the optimal approach. This is the code for this mathematical approach.